As our user base grows, a single server isn't enough to handle the increased demand, and to accommodate more users, we can separate our web tier, which is handling the web and mobile traffic, and the data tier, which is managing the database. This setup enables us to scale each server based on its specific load. But when it comes to choosing the right database, how do we know which specific database is the best for our specific application? When it comes to database selection, there are two main options. The first option is relational databases, or RDBMs, which are structured in tables and rows. Some popular examples are PostgreSQL, MySQL, Oracle Database, or SQLite. On the other hand, we have non-relational or NoSQL databases. These are suited for applications that require flexibility and fast access to large volumes of unstructured data. Some examples are Cassandra, MongoDB, Redis, or Neo4j. Let's start by exploring the relational databases. These databases use structured query language or SQL for finding and manipulating data. The data here is structured in tables, which are the fundamental building blocks of SQL databases. And these are similar to spreadsheets. Each table consists of columns, which can be thought as the fields or attributes of the table. And it also consists of rows, which are single records within this table. For example, if you imagine a customers table, within this table we can have columns like ID, name, age, and email. And for each rows, we can have specific customers like the ID of 123 and the name will be John and the age will be 30 and so on. But what are the advantages of using an SQL database? First of all, they support complex join operations across multiple tables. For example, if you imagine we have a customers table and also a products table, and now we want to create a separate table that will connect the customers and the products that they have ordered. With SQL, you can join these two tables together into an orders table, and this will hold the information about the customer IDs who have this order and also the product IDs which this customer has ordered. And this process of combining two or more tables into one table are called join operations in SQL. And the other big advantage is they provide robust data consistency and integrity, especially for transactions. Transactions in SQL are a sequence of one or more SQL operations that are performed as a single atomic unit, and each transaction in SQL follows the ACID acronym. You can think of a transaction example like a bank transfer. So first of all of the transactions are atomic, which means that the entire transaction is treated as a single unit, which either completely succeeds or completely fails. Each transaction is also consistent, which means that it transforms the database from one valid state to another valid state. And they also come with isolation, which means that modifications made by concurrent transactions are isolated from one another and they don't interfere with each other. And lastly, they come with durability, which means even if the system fails or the database server fails, the data will still remain there. And now let's have a look at non-relational databases. A quick note, this lesson is just one part of my complete system design course, where I cover everything from database scaling to caching, CDNs, and much more. And if you're enjoying this and want to dive deeper into mastering system design, then check out the top link in the description. Non-relational databases can be in different forms. For example, we have document stores like MongoDB, or you can use wide column stores like Cassandra, key value stores like Redis, and graph stores like Neo4j. Let's have a look at each of these types separately, and let's start with the document stores. MongoDB is the most popular example of a document store, and the data here is stored in JSON-like documents, which allows us to have complex data structures within a single record. Next, we have wide column stores, where data is stored in tables, rows, and dynamic columns. Some examples here are Cassandra or Cosmos DB. The main advantage of these databases is they can handle massive scales and are very good for many write operations. The other option is graph databases, which focus on storing the entities and their relationships as graphs. An example of a graph database is Neo4j. For example, in Amazon, they use the Neptune graph database, which helps them to make you product recommendations based on your previous orders. And the other popular type is key value stores. Here data is stored in key value pairs. The biggest advantage of key value stores is their simplicity and speed. Since they are primarily stored in RAM, reading and writing to these databases is extremely fast compared to other databases. Some examples of key value stores are Memcache or Redis. So that's the main 4 types of NoSQL databases. Now let's have a look at the advantages of these NoSQL databases. If you have a look at the same example that we had for the SQL databases, where we have customers and products and we want to join them in orders. For example, in MongoDB, you could have this as a single document, so you could store all of the user data, also the orders and products in a single document. And because of this structure, the NoSQL databases can handle highly dynamic and large data sets without the structure imposed by relational databases. And also, they are optimized for low latency and scalability. So when should you use relational versus non-relational databases? Here is a quick comparison of both. If your application data is well structured with clear relationships, then you should use SQL databases. For example, if you have an e-commerce application tracking customers and orders, that's a good use case of using an SQL database. Next, if you need strong consistency and transactional integrity, for example, if you have a financial application or banking system, then you should use the SQL databases. However, if your app demands super low latency for quick responses, then you should go with non-relational databases. Or if the data is unstructured or semi-structured, like JSON objects, and the relationships aren't that crucial, then you should also go with NoSQL databases. And lastly, if your application requires flexible and scalable storage for massive data volumes, for example, a recommendation engine storing user activity data and key value format, then you should also go with NoSQL databases. This wraps up our lesson on databases, but it's just a small piece of the puzzle. If you want to take your system design skills to the next level with hands-on exercises and step-by-step guidance, then check out my complete system design course in the description.